3, we're going to talk about just similar triangles, okay? And just like with congruent triangles, we had shortcuts. The same goes for similar triangles, okay? So the first shortcut is going to be angle-angle similarity, okay? And for two triangles to be similar, we only need to know that two pairs of corresponding angles are congruent, okay? Without knowing anything about sides, if I know that two pairs of angles, so in this case, angle A and angle F, are congruent, and angle B and angle G are congruent, then I know that my triangles are similar. Okay, so that's one of our shortcuts. The second shortcut here is side-side-side similarity. Okay, now our sides, remember, don't have to be congruent, but our sides have to be proportional. Okay, so when we match up those corresponding sides, for instance, not LG, LJ, and QM, then we've got JK and MP, and last but not least, we've got LK and QP. If we know that they are all proportional, all of those sides are in the same ratio, then we know that our triangles are similar as well. So triangle LJK is similar to triangle QMP. And our last shortcut here is side angle side. Okay, so again, if we've got two pairs of sides that are proportional, and that included angle, so that angle that is a part that is created by, it says included. Okay, so if that two sides are proportional and that angle that's created by those two pairs of sides are congruent, then the triangles are similar. Okay, so here I've got RS and XY as corresponding parts, and then I've got ST and YZ as corresponding parts. Okay, so I know they are proportional. And then if we look, angle S here is between RS and ST. And angle Y is between XY and YZ. Those are congruent. I don't need to know anything else to be able to say that triangle RST is similar to triangle XYZ. Okay, so now we're going to put these into action here. Okay, determine if the triangles below are similar. If they are, write a similarity statement and explain your reasoning. Okay, and that reasoning is just going to be which similarity shortcut are we using. So this first one, I see I've got a 57-degree angle and a 48-degree angle. Okay, so if you'll remember, triangles have 180 degrees on their interiors. So 180 minus 57 minus 48 tells me that angle K is 75 degrees. Okay. But in the second triangle, I've got a 75-degree angle and a 57-degree angle. Okay, that leaves me with 48 degrees to go for angle Q. Okay, so I know here I've got at least two pairs of corresponding angles that are congruent. So by that angle-angle similarity, I can say that triangle LJK is similar to triangle MQP. Okay, and remember that how you name that first triangle doesn't matter, but that second triangle, the way you name it has to match up those corresponding parts. Okay, example 2, I'm going to start the same way. I know 2 angles, but I'm going to find that third one. Okay, because right now I only see one pair of matching angles in those at angle C and angle D, both being 90 degrees. Okay, so 180 minus 90 minus 44 makes angle A 46 degrees. Okay. And I'm pretty sure I know where we're headed with this one, but just to double check, that's an 8. 180 minus 90 minus 47 gives me 43 degrees for angle G. Okay, so I only have one pair of congruent angles, so these triangles are not similar. Okay, example 3, I see these symbols here on these 2 line segments means that they are parallel. Okay, parallel lines, I want you to think about corresponding angles. Okay, so angles that are in the same corner of those 2 different intersections. I'm going to write that here, corresponding angles. Okay, and so that gives me 2 pairs of corresponding angles that are congruent. So that is my angle-angle similarity, which lets me say that triangle LPQ is similar to triangle LJK. All right. Example 3 here, I'm trying to determine if triangle AEF is similar to triangle ACB. Okay. So 8 plus 4 is 12, and 10 plus 5 is 15. All right. So remember, anything to do with sides in similar triangles, we have to determine if they're proportional. Okay, so 8 and 12 correspond with each other. 10 and 15 correspond with each other. Okay. To determine if a proportion is true, we just have to cross multiply. Okay, 12 times 10 is 120. 8 times 15 is also 120. Okay, so that gives me a side and a side. I don't know anything about the third side, so now we have to determine if we've got a pair of corresponding angles. Okay. Now, these 2 triangles that are, one is basically right on top of the other one. They share this angle A, so that's my angle. So by side angle side similarity, triangle AEF is similar to triangle ACB. Okay. We can use these shortcuts to help us find missing parts of triangles, okay, missing sides of triangles. So in this first one, we first had to identify the similar triangles, okay? So I see that triangle MQN is similar to triangle MPO. Okay. Once I've identified those similar triangles, I'm just going to set up a proportion here. Okay, 5 matches with 5 plus x. Okay. And then 6 matches with 9 and 3/5, so 9.6. Okay. When I cross multiply 9 and, nope, I'm sorry, 5 and 9.6, that gets me 48. Okay, remember I'm taking 6 times all of that, so 6 times 5 is 30, plus 6x, not 5x. Okay, subtract 30 from both sides, I get 6x equals 18. So my x value is 3, for example number 5. Okay. Example number 6 here, it looks like W and T correspond to each other. So when I'm writing my similarity statement, they're going to go in the same spot. Okay, I also have a pair of vertical angles here. And then S and V. So these are similar by angle, just like number 5. Okay, so 8 and 10 correspond to each other, just like x plus 6 and 2x plus 6 correspond to each other. Okay, to solve a proportion, we cross multiply. So I have 8 times 2x is 16x. 8 times 6 is 48. And then I've got 10x plus 60. 10 times x and 10 times 6. Okay. We're going to move all of the x's. I'm going to move all the x's to the left and subtract 48 from both sides. So that leaves me with 6x equals 10, 12. So not 12. X is not 12. X is 2. Okay. Example 7 here. Again, I've got those parallel lines. Okay, parallel lines, when you see parallel lines, that's angle, angle similarity. Okay, so triangle SRT is similar to triangle VUT. Okay, 14 and 6 are corresponding sides. Okay, 14 comes from triangle SRT. So when we're writing the expression, we need to write the sum of those two expressions here. So 3x plus x is 4x. A negative 3 plus 2 is a minus 1. And then just over that x plus 2. Okay, so we cross multiply. 6 times 4x is 24x. 6 times negative 1 is minus 6. And then we've got 14x plus 28. 14 times the whole quantity, x plus 2. If I subtract 14x and add 6 to both sides, that gives me 10x equals 34. And 34 divided by 10 tells me that x is 3.4. Okay. We've got parallel lines here again. Okay, but this time we're looking at alternate interior angles. Okay, and if you want to throw these in here, we've got a pair of vertical angles. Okay, so 16 and 4, those are corresponding sides. And then x plus 18. and x minus 3 are corresponding sides as well. Okay. Cross multiply, get 16x minus 48 equals 4x plus 72. Okay. Subtract 4x gets me 12x. If I add 48 to 72, that gets me to 120. So my x value is 10 for these similar triangles, KJL and MNL. All right, last two examples here. We are going to use similar triangles to find a measurement of something. Okay, this is called indirect measurement. It says Hallie is estimating the height of the Superman roller coaster in Mitchellville, Maryland. She is 5 feet 3 inches tall. Okay, so we've got Hallie here. Now remember, 5 feet 3 inches is actually 5.25 feet. Okay, and her shadow is 3 feet long. So here's our triangle. Okay, here's our roller coaster. That's what we don't know how tall it is, but we know that its shadow is 40 feet. Okay. How tall is the roller coaster? So we can use similar triangles and proportions to find the height of things that we don't know how tall they are. Okay, so 5.25 and our missing side are corresponding parts, and then 3 and 40. The shadows are matching parts. Okay, so 40 times 5.25 is 210. So we've got 3x equals 210. Divide both sides by 3. That Superman roller coaster, according to our calculations, is 70 feet tall. Okay. Adam is standing next to the Palmetto Building in Columbia, South Carolina. He is 6 feet tall. And the length of his shadow is 9 feet. Here's our building. Its shadow is 322.5 feet long. And again, we don't know how tall that building is. Okay, so the heights of our objects match up. The shadows of our objects match up. When we cross multiply, 9 times x is 9x. 6 times 322.5 is 1,935. And divide both sides by 9. The height of that building is 215 feet.